everyone, welcome to my YouTube channel. Before you is a presentation I bring to you. It's a school project presentation, and in this presentation I'll be bringing you the exploration of the data analysis in my project, and this will help me in predicting, like determining which model I can be using in performing my algorithms, as in getting the results and so on. So in this presentation, I bring you the, the techniques that I will be using and some of the illustrations about my project, like the graphs, correlation matrix, and many more. As you see here in the first slide, I give you the title of my project, and it is all about predicting the students' performance in exams using AI and machine learning. Sarah Adiao is my name. I'm the one who wrote it, and I'm presenting it. My school, as you can see all, when you go to the next slide, data cleaning and exploration analysis, I define it here. It refers to the process of maximizing raw data and condensing it to a more usable form. Actually, it makes me to do a lot of things in it, like cleaning my data set, and it involves a lot of process, as in listed below. One of them is removing duplicates, removing irrelevant data, standardizing capitalization, converting data types, clear formatting, fixed errors, language translation, and handling missing values. And all these formulas, or all these lists of the methods will be applied on my data set that I'm going to be using while predicting the students' performance. When you come down here, we find we talk about heat maps. A heat map refers to the graphical representation of data where values are depicted. They're actually depicted in the form of color. As you see here, there are so many colors here. Like I see like 3 to 4 colors, and when you see the colors, there are those ones giving the good color. Then those ones dark means that some things have to be improved. Like for example, here this heat maps I've given here, it is for the clean data and unclean data. When you check here in the first one, the heat map for unclean data, you find that the visited resources, because in my data set there is a column for visited resources where students can visit, read them before they do the exams. It means that students don't perform very well in that they don't visit a lot of resources, like they do research before doing their exam. So it means that this gives me a clue that I should actually improve on this, how students should, the rate at which they can actually visit the resources before they sit for the exam, so as to improve their performance. You come down here, there is also a pair of plots that I made on my data set. It gives me a variation of different columns in my data set, like for example, raise hands, the number of times students can raise hands, visit resources, discussions, and many more. When you go down here, I'll talk about the box plots. The box plots below actually show the variation in gender of students in participating in discussions, as more females do more than males, as also for raising hands in class. Majority of students don't raise hands. As you can see here, this color blue shows that it is a medium performance. And when you see in like the next one for the female, when I talk about this graph alone, for the box plot, the female students are moderate. And when you come to class and raising hands, low, like when you see the low, the medium, and the high, very few students raise hands, as I talked about earlier from the previous slide. When you come to the next slide, you find that you get about talk about correlation matrix. Correlation matrix gives us the variation in comparison to two or more columns, giving us how one column can affect the other. When you talk about correlation here, it is the null statistical method that is used to discover if there is a relationship between two variables and how strong that relationship may be. As you can see here, I compared in the student's absence days, depending either the student was absent from school under 7 days in a week or above 7 days in a week. And it shows us in their performance also that the students who were absent from school before under 7 days, they performed better because the green one says higher performance, and this maroon one, this orange one shows the moderate performance or average, then this one is a low one. You see, students who were absent from school above 7 days, like more than a week, their performance is really too small, as you can see the green bar here. The same applies to the students who have their caregivers as father or a mother, the students who depend on the mother as their giver of things perform better than students who have their fathers as their what? Their caregivers. You can see that is all about the correlation matrices I was able to get. Then you talk about the outliers here. Outliers refers to an observation that lies an abnormal distance from other values in random sample of data. As you can see here, I'm able to detect that abnormal behavior, the variation, like the values that have the low performance grade. As I compare here for the count, I performed the count plot, and you can see that the grade ID for 05 and 09 and 10 have the low values, as you can see here. I already explained it, and therefore they become our outliers. They have very low values as compared to other grade IDs. When you come down here to the next slide, I will say feature independence. I was just able to create like independent plots for respective columns for the class and the gender, female and male. You find that male students are very many than the female students. And when you come here about the class performance, medium, low, and high, the medium students' performance is more as compared to the rest of the two. When you come down here, you talk about the illustration of patterns. Illustration of patterns of interest. I'm always interested in the thing, how performance of students in these topics. There's math, IT, Arabic, science, English, Quran, Spanish, French, history, biology, chemistry, and many more. But you find that in the performance in geology, you find that students here, none of them was able to fail, all of them were able to pass. That's why I was interested in getting this. So I was illustrating the patterns of interest. When you come in the down slide, we talk about an end-to-end machine learning pipeline. This involves transforming each step into separate models, mapping the machine learning pipeline architecture, or stretching the machine learning pipeline, optimizing and automating each step of machine learning pipeline. It's like building a strong model, like identifying which model is the best while training my data set. So when you come down here, data cleaning and exploration. Data cleaning actually involves, like I already told you, cleaning the data set, making it more useful than it would be. Like here in my data set, I got it from Kaggle. I had to drop the columns that were not necessary because I'm not interested in the parents' school satisfaction, parents' answering survey, and announcements view. I had to drop them and I'll remain with the list of all these, as you can see. Then it also involves translating the categorical data into numerical data, as shown below. This is the sample for the X train when you're dividing like the data set, you split it into trains and tests. That's what I showed here. When you come down here, you say splitting data set into train and validation and test. Data splitting refers to when data is divided into two or more subsets, but majorly divided into two. That's X and Y. One part can be used to evaluate or test the data set, and other part can be used to train the model. And these diagrams below I showed you some of the plots, like the graphs for the Kenneth classifier and random forest classifier respectively. So you'll be performing them so that you can get the best performance model. Tuning operators also like the same as I talked about. Apparatus tuning refers to the process of searching for the ideal model architecture and hyperparameters that define the model. They actually define which model I can go with. Here is a sample of the confusion matrices that I plotted, and I came up with this four matrices. So it gave me to choose the support vector classifier at the base because it has a lower value, as you can see from the diagram. So when I come down here, I talk about the evaluation and validation set. After all that validation, analysis, and everything, I came up with all this, as you can see. Random forest classifier with 99%, then support vector classifier with 100%, and decision tree classifier with 90%, and Kenneth neighbor with 72%. So, and therefore, I can conclude that I'll be using the support vector classifier as my training model for my dataset as I will be doing this project of mine. I want to thank all of you for watching me right now and for giving me your time. I will be uploading more videos about this project. Thank you.